It started as a routine observation. Nothing dramatic, nothing unusual, just another NASA livestream tracking 3I/ATLAS as it made its way around the sun. Thousands of viewers, astronomers, amateurs, students, had the stream running in the background, expecting nothing more than the familiar glow of a comet illuminated by solar glare. For weeks, NASA had streamed every update without hesitation, but on November 9th, something broke that pattern. At exactly 2:13 UTC, the feed stuttered. A frame froze. The usual telemetry numbers, velocity vectors, coma temperature, solar wind interference, flickered erratically. Then the image shifted into an angle no one had seen before. The camera auto-corrected, sharpened, and snapped into focus on something that didn't look like comet dust, didn't look like a fragment, and didn't look like anything a natural object should produce. The frame lasted precisely 3.7 seconds. Enough time for screenshots, enough time for analysts to grab optical data, enough time for NASA to see what everyone else saw, and panic. Then the feed went black. Not paused, not buffering, manually terminated. The title card instantly replaced with a message no live stream from NASA had used in years. Signal acquisition interrupted. Please stand by. Except the signal never returned. Within minutes, NASA's official X account quietly deleted the link to the live stream. Telescope mirrors at ground stations shifted toward other objects, and the Deep Space Network's public dashboard showed Atlas being transferred from an open access category to a restricted internal monitoring tag normally used only for classified spacecraft. What viewers caught in that final frame was strange enough that Discord servers, astronomy forums, and subreddits exploded within the hour. Some saw two symmetrical blue jets. Others swore they could make out hard geometry, flat planes, edges, not debris. A few observers claimed they recognized the same collimated jet structure the British Astronomical Association had photographed days earlier. One thing was certain, NASA didn't want anyone seeing the next frame, because whatever Atlas was doing at the moment the live stream cut, it wasn't behaving like a comet. And the timing of the blackout, right when those jets aligned into view, was far too convenient to ignore. The question wasn't just why the feed went down, it was what NASA saw that made them shut it down. Long before the live stream blackout, astronomers already knew Atlas wasn't ordinary. Objects like this don't just drift into our solar system by accident. Only 2 interstellar visitors had ever been confirmed. Oumuamua in 2017 and 2I/Borisov in 2019. Each carried secrets from beyond our star system. But 3I/ATLAS, this one was different from the moment it was found. On July 1st, 2025, Chile's Atlas Survey Telescope cataloged what appeared to be a faint, elongated object moving against the star field. Its trajectory alone was a shock. It wasn't just passing by. It was diving into our inner solar system at an angle no typical comet takes. Right away, researchers recognized something strange, the object's origin point. Based on its velocity vector, ATLAS likely came from a different stellar neighborhood entirely, one older than our sun. That meant whatever this thing was, it carried chemistry forged under a different star, perhaps billions of years before Earth's oceans even formed. At first, astronomers tried to fit it into the category of hyperactive interstellar comet, a convenient label that allowed everyone to move on with their day. But the numbers cracked that illusion instantly. For one, its coma didn't behave like a normal dust cloud. Webb's early scans showed structures inside, striations, folds, and filaments that looked less like random ice crystals and more like aligned internal features. Second, its blue glow was a problem. Natural comets glow white, yellow, sometimes green. Blue requires extreme temperatures or ionization far beyond ordinary sublimation. Yet Atlas burned bright electric blue for weeks. Third, the iron-nickel ratios inside its gas were wrong. Not unfamiliar, wrong. As if the material had been processed, not naturally formed. And then there was the velocity. It moved too smoothly, too efficiently, almost like it was correcting its own path as it approached the sun. Astronomers tried to brush it off. NASA stayed quiet. But as Atlas got closer to perihelion, the anomalies compounded until the scientific community realized something uncomfortable. This wasn't just an interstellar visitor. It was an interstellar question mark. Everything changed with the James Webb Space Telescope's first serious observation of Atlas. JWST is designed to see the universe in ways no human eye can. infrared, thermal, molecular signatures. When Webb turned its NIRS-PEC instrument toward the object in late August, astronomers expected to see typical comet activity: water-ice sublimation, dust clouds, maybe a few jets. What they saw instead broke every model they had. Webb captured a colossal CO2 coma stretching 348,000 kilometers across, nearly the distance from Earth to the Moon. That alone would have made Atlas the most extreme comet ever recorded. But the deeper chemical readings were what sent alarms ringing through observatories worldwide. The ratios inside the coma didn't match any known interstellar ice. Iron and nickel were present in strange proportions, as if the interior material had been melted, filtered, or processed through some mechanism. Several molecules Webb detected shouldn't have survived the object's journey through cold interstellar space. Others shouldn't exist naturally at all. Then, NIR spec recorded something far more disturbing: temperature inconsistencies. Comets heat up as they approach the sun. That's normal. But Atlas wasn't heating uniformly. It had pockets, hot zones deep inside the nucleus, as if something internal was generating heat, not the sun. Thermal gradients lined up in repeating geometries for days at a time. Natural comets do not maintain stable geometric heat patterns. They rotate, they crack, they erupt unpredictably. Atlas didn't. At this point, NASA quietly increased the Livestream resolution from the solar monitoring satellites. Internal memos, later leaked, revealed that mission teams were told to flag internal structural anomalies, a phrase typically used when tracking spacecraft, not comets. Researchers in private chat groups began calling Atlas the object, no longer comfortable calling it a comet. A few NASA engineers grew concerned enough to question whether something inside the object was still active, whether Atlas wasn't simply reacting to sunlight, but responding to it. When the team cross-checked the thermal data, the truth was impossible to ignore. Something inside 3I/ATLAS was heating itself. Something inside was operating, and that was the first undeniable sign that this object was not behaving like anything nature had ever produced. By early October, astronomers monitoring Atlas noticed something that should have been impossible. The object wasn't losing speed as it approached the sun. It was gaining speed. Every celestial body entering perihelion, asteroids, comets, dust, anything, experiences predictable acceleration strictly defined by solar gravity. But Atlas wasn't following the curve. It was outrunning it. The numbers leaked first from Harvard's monitoring logs. Radial acceleration, 1.1 times 10 to the power of -6 astronomical units per day squared. Transverse acceleration, 3.7 times 10 to the -7 astronomical units per day squared. Combined, that translated to a boost of 94 kilometers per day squared at perihelion. Imagine an object already moving at 150,000 miles per hour, suddenly finding more speed. No gravitational slingshot, no debris collision, no visible thrust, just acceleration. Astrophysicists had only one natural explanation: outgassing. Comets build pressure inside their cores, then vent gas in random bursts, giving them small pushes. That's normal. But Atlas wasn't venting randomly. Its speed was increasing smoothly, consistently, and in sync with its strange internal heat signatures. Then the mass loss readings came in. In early August, Atlas was shedding 330 kilograms per second. By late October, it was shedding nearly 2 million kilograms per second, a 6,000-fold increase. That number broke the model instantly. To lose that much mass under natural sublimation, Atlas would need to have a surface area of 617 square miles, roughly a sphere 14.3 kilometers wide. But 3 weeks after discovery, the Hubble Space Telescope had measured the nucleus at only 1 to 2 kilometers across. The math didn't just break, it collapsed. Either the object somehow grew 16 times larger in a month, impossible, or the object shattered into multiple fragments, increasing total surface area, or something inside the object was producing thrust, far beyond natural sublimation. That's when Loeb stepped in. And when he ran the calculations backward, he discovered something chilling. For the numbers to work, Atlas needed exactly 16 fragments. Not 10, not 20, exactly 16. Each fragment adding surface area, each acting like a functioning piece of the whole. Physics wasn't just being broken, it was being rewritten. By mid-October, amateur astronomers started asking the same question. Why was Atlas glowing blue? Not icy white like most comets, not green like cyanogen comas. not yellow like sodium emissions, blue, electric blue, a shade so bright and so unnatural that even people with low-end telescopes could see it. NASA tried to dismiss the phenomenon as ionized carbon dioxide interacting with solar wind, but that explanation didn't survive even the first detailed analysis. The temperature required for that shade would push the interior of Atlas above thresholds known to melt, vaporize, and obliterate cometary material. Yet the object held together. Even stranger, the blue intensity wasn't uniform. Observers in Italy, Japan, and Arizona captured synchronized pulses, faint brightening cycles, almost rhythmic, repeating every 9.4 minutes. Natural objects don't pulse. They erupt chaotically or glow steadily. But Atlas seemed to be signaling, cycling, responding to an internal process. Then came the structure. High-resolution images revealed straight-line patterns inside the coma, almost like ribs or internal framing. Dust clouds should appear as swirls and scatter, but inside ATLAS, the glow fell along geometric lines. A researcher from the University of Hawaii noted the strangest detail. The blue areas correlated with the same internal hot zones Webb detected weeks earlier, meaning the glow wasn't sunlight, it was heat. Heat coming from the inside. Even comets with extreme outgassing don't heat from their cores outward. They heat from their surfaces inward. Atlas reversed that pattern entirely. NASA increased livestream monitoring at this point. Cameras zoomed closer. Filters changed. The team studied the pulse intervals. Then, during a routine feed, the object brightened sharply, far beyond previous pulses. Not a flare, not an eruption, more like a surge. Viewers saw thin, concentrated lines extending from the nucleus, 2 of them, perfectly symmetrical, like beams or jets, not chaotic, not random, aligned. And that was when things began moving toward the blackout moment. Because once Atlas glowed blue and formed symmetric jets, the comet idea didn't just look weak, it looked impossible. The breakup event should have ended the mystery. Comets fragment, they crack, they fall apart. Astronomers have seen it dozens of times, but Atlas didn't break apart like a natural comet. It separated. On November 3rd, multiple observatories reported a sudden increase in brightness and a strange expansion of the coma. NASA labeled it a significant fragmentation event. The term was technically accurate, but deeply misleading. When the dust cleared, ATLAS wasn't in pieces. It was in fragments. 16, exactly 16. This number matched Loeb's calculations perfectly, giving each fragment a surface area that, when combined, fit the previously impossible sublimation math. The symmetry was too neat to ignore. Even stranger, the fragments weren't drifting apart chaotically as debris normally would. They arranged themselves. High-precision telescopes in the UK, Chile, and Australia all documented the same formation. A radial pattern, even spacing, controlled orientation, like pieces of a system separating into operational units. Then observers noticed each fragment was producing its own jets, individual directional jets, aligned to the same angles. Not random, not shifting. Stable, precise, engineered looking. NASA tried to contain the narrative by calling it a rare, highly active disintegration. But disintegration doesn't produce clean geometry. It produces chaos. Atlas produced order. A researcher with ESA leaked a line from their private notes. Fragmentation behavior inconsistent with thermophysical modeling. Movement suggests coordinated thrust. That's when NASA increased monitoring of the object's trajectory. That's when the live stream got more views than any Comet stream in years. And that's when NASA noticed something disturbing. The fragments weren't slowing down. They were accelerating. Atlas didn't lose structural integrity at perihelion. It unlocked something. Because what appeared to be an explosion behaved more like an activation. 16 fragments, 16 jets, 16 stable trajectories, like a system coming online. And just as the fragments formed their perfect pattern, NASA's live stream zoomed in. And the blackout hit. The images that started the firestorm didn't come from NASA or Hubble. They came from 2 British astronomers, Michael Butner and Frank Nebling, using a ground-based telescope network that specializes in tracking fast-moving near-Earth objects. Their November 9th photos, captured just hours before the NASA live stream blackout, revealed structures that shook the scientific community. The first shock was the anti-tail, a narrow beam of dust and gas pointing toward the sun instead of away from it. Anti-tails form occasionally in comets, but never like this. Atlas's antitail was almost perfectly straight, almost perfectly symmetrical, and nearly 950,000 kilometers long, a straight celestial line extending from an interstellar object, pointing directly at the sun. But that was only the beginning. The second image captured a main collimated jet stretching 2.85 million kilometers across space. Collimated means narrow, focused, laser-like, something comets simply don't produce. Natural jets spray dust in irregular patterns. They blur, they wobble, they twist unpredictably. Atlas's jet was stable, straight, structured. The British team assumed they had made a processing error. They recalibrated their instruments, reran the stack, rechecked alignment. The jet remained. Clear, precise, a line, not a plume. Then came the third image, the one that forced NASA to classify the ATLAS stream. Buttner and Nebling captured 7 distinct jets, all aligned at consistent angles, radiating from the central nucleus in a repeating geometric pattern. They weren't spaced randomly. They appeared evenly distributed, like points on a machine or nozzles on an engineered object. The images spread across astronomy forums within hours. A European astrophotographer noted the symmetry suggests controlled exhaust. A researcher in Arizona wrote on his private Discord, "This looks like thruster alignment, mechanical, not fracturing." The phrase engineered jets began trending. NASA remained silent. The Harvard team refused interviews, and small observatories worldwide began capturing their own versions of the same bizarre structures. In every case, the pattern held. Atlas wasn't venting, it was firing. Whatever those jets were, they were directional, repeatable, geometric. They didn't resemble a natural comet, they resembled a propulsion system. At 2:13:06 UTC, NASA zoomed in. At 2:13:10 UTC, viewers saw something that no one expected. An image so crisp it didn't look like comet dust or faint gas trails. It looked like a structure. The frame showed one Atlas fragment, fragment B, passing through a high albedo region of sunlight. For the first time, the jets weren't stretching tens of thousands of kilometers into space. They were originating from specific points on the fragment's surface. 2 jets, perfectly parallel, identical in thickness, aligned at an exact mirrored angle of 31 degrees. Symmetry like that doesn't occur in comets, ever. A dust jet forms wherever volatile ice cracks. It erupts randomly, chaotically. When a comet rotates, the jets smear across the coma. But Atlas's jets were stable and fixed. As the fragment rotated, the jets compensated, bending slightly to maintain direction. Viewers watching the live stream noticed the jets move with coordination, almost like gimbaled exhaust. Then the fragment brightened for half a second. Not a flare, not sunlight, a pulse. People watching live took screenshots instantly. Several frames captured what looked like a sharp outline. Edges, angles, a boundary too uniform for debris. And then, the moment the outline sharpened, the feed cut. NASA didn't lose signal. They terminated the stream. Within 30 minutes, NASA issued a vague statement. Solar interference caused unexpected sensor dropouts. Except solar interference doesn't cause manual feed termination. It doesn't trigger priority file locks. It doesn't remove stream links from NASA's website. Reddit and astronomy Discord servers reconstructed the final frame using over 400 user-submitted screenshots. The enhanced composite revealed something chilling. A fragment shaped not like ice, but like a smooth, curved object. 2 symmetric blue jets producing clean collimation. A faint internal glow pulsing from the core. No debris trail, no irregular shadowing, no rough surface. The more analysts enhanced the frame, the less it resembled a comet fragment, and the more it resembled a manufactured component. NASA refused to comment further, because if that image was real, then ATLAS wasn't just breaking apart, it was activating. On November 10th, after weeks of silence, Loeb finally released his analysis. It was calm, technical, peer-reviewed, but beneath the equations and mass loss curves was a message that hit the scientific world like a shockwave. 3. I/ATLAS's fragmentation may represent a controlled mechanism. Loeb never uses sensational language. He doesn't need to. His math does the talking. The Harvard paper outlined 7 anomalies that natural physics cannot explain. Acceleration without force. No known comet can gain velocity so cleanly. Perfect fragmentation into 16 units. No randomness. No shrapnel. Symmetric mass distribution. Fragments matched ideal surface area totals. Directional jets. Precisely aligned thrust-like emissions. Sustained collimation. Dust jets that behave like engineered exhaust. internal heat generation, uncorrelated with solar input, blue emission pulses, suggestive of ionized high-temperature energy. Then the line that changed everything. If natural sublimation cannot account for the observed acceleration, technological thrusters provide a viable alternative. That wasn't a claim. It wasn't a declaration. It was a doorway. Loeb proposed multiple possibilities: an ancient interstellar probe shedding components, a multi-stage object activating secondary units, a self-disassembling artifact using solar proximity to trigger deployment, a mechanism older than recorded human history. He emphasized that Atlas's observed behavior required extremely efficient exhaust velocities, far beyond ice sublimation and perfectly consistent with small-scale propulsion. His conclusion was intentionally neutral, further monitoring necessary, natural explanations increasingly inconsistent. Meanwhile, NASA refused to answer questions about the Livestream blackout. ESA declined interviews. The British Astronomical Association simply reposted their images without commentary. But within the scientific community, the conversation was already shifting. Not is ATLAS a comet, but what system is ATLAS executing? Because every piece of data pointed toward a single, uncomfortable truth: Atlas wasn't falling apart. It was following a sequence designed somewhere beyond our sun. As 3I/ATLAS drifted away from the sun, broken, glowing, accelerating, astronomers expected the fragments to behave like any normal debris cloud: chaotic, unstable, unpredictable. Instead, the opposite happened. Something far stranger, far more unsettling took shape. Each of the 16 fragments maintained coherence. Not one disintegrated, not one tumbled out of formation. Even more unnerving, each fragment continued producing the same directional blue jets. Jets that stayed aligned with mathematical precision despite fluctuations in solar wind pressure. Natural objects don't do this. They spin, they wobble, they decay. But Atlas's pieces behaved like independent units being guided by an internal set of instructions. By November 18th, researchers in Italy, Chile, and Australia all reported the same pattern. The fragments were spreading out in a formation that looked less like an explosion and more like deployment. Picture the petals of a flower blooming outward. Picture pieces of a system separating not because they're failing, but because they are entering the next phase of operation. That idea terrified astronomers far more than the possibility of alien technology, because deployment implies purpose. The formation resembled something no comet breakup has ever produced: a radial grid, evenly spaced, each fragment accelerating at a rate proportional to its mass. Observers noticed faint trails, thin, almost laser-like streaks, connecting several fragments through the dust, as if they were exchanging material or maintaining alignment. Then came the unexpected. One fragment, cataloged as Fragment L, produced a sudden flash of blue far brighter than anything recorded before. For exactly 0.8 seconds, Fragment L emitted a columnated jet directly toward another fragment, Fragment H. The two fragments responded by adjusting position, shifting by tiny but measurable increments. It looked like coordination. Astronomers who witnessed the event privately described it as communication through thrust. NASA declined to confirm the observation. ESA refused comment entirely. Harvard's team responded only with a single statement. The fragments appear to maintain non-ballistic motion. Non-ballistic, meaning not following gravity, meaning not natural, meaning something inside those pieces was making decisions. As Atlas moves toward the outer solar system, every fragment continues its silent path, glowing electric blue, shedding mass at rates no natural process can sustain, all while drifting farther from each other in a symmetrical, stable pattern. If this were destruction, the debris field would collapse. If this were failure, the jets would die out. Instead, the system remains eerily functional. And that brings us to the question humanity is not prepared to answer. Are we witnessing the death of a comet or the activation of an interstellar mechanism older than Earth? Because if Atlas didn't break apart by accident, if those 16 fragments represent stages, if the jets are controlled, if the geometry is intentional, then we didn't just lose a comet. We witnessed something complete a sequence, something not made here. Something that did exactly what it was designed to do, at the exact moment it reached the sun.